All right, so we got part 2 right here of graphing two variable inequalities. All right, so we got a word problem. Dominique can spend up to $20 to provide the dance squad with drinks after their practice. A bottle of water costs 80 cents and a sports drink costs $1.25. How many bottles of water and sports drinks can Dominic buy for the dance squad? So the way that we can answer this is, or actually the way that we can think about it is, there are several different answers. There's several combinations, because if you think about it, what happens if I decide, or Dominic decides to buy 5 waters, right? 5 waters. What's the common sense math that you would do? So if you know you're going to buy 5 waters, that means you're going to be doing 5 times the cost of the water, which is 80 cents, right? And then you're going to see how much money is left over. So this will be the cost of the water. And then you would have, okay, so starting with 20, take away that cost of the water, and then that will give you what you have left, right? Well, that is the type of math that you would have to do over and over and over and over again to find out all your different combinations, right? Because all this math will only tell you what you can get with a combination of 5 waters, right? So I don't want to sit there and say, okay, how many can I buy? How many sports drinks can I buy if I have 6 waters or 7 waters or 8 waters? So by doing inequality and being able to graph it, we can see very, very quickly all those combinations. So that is exactly what we're going to do right now. We're going to set up the inequality and graph it so we could see what all those combinations are. So let's go ahead and start with common sense. How much money does he have? Dominic has $20 to spend, right? Next, how much are the expenses? Expenses. The expenses are the 80 cents. Okay, he's going to be spending 80 cents for every single water. I don't know how many waters he's going to buy, so we do need to put variables here, right? So I'm going to go ahead and say that X is going to be waters, water bottles. So I'm going to put that. And then additionally, we're also going to be adding more expenses if he does decide to also get sports drinks. $1.25 for every single sports drinks. We're going to go ahead and call that Y. So that is going to be sport drink. Okay. So now that we have this here, we need to finalize our inequality symbol, right? If you think about it, can the expenses be more than the amount of money that you actually have? It cannot. Expenses cannot be more than the amount of money that you have. So that means that the amount of money that we have needs to be more or equal to, because we could, or Dominic can actually spend all the $20 buying this stuff, right? Buying these drinks. So, all right, so that's step number 1, creating the inequality. Step number 2 here would be, let's start graphing it so we can have a visual and quickly be able to see all our answer combinations that we have. So remember that to graph this, we want to put it in slope-intercept form. And that is when we get Y and have it by itself. So what I'm going to do right now is I'm actually going to flip the entire thing, just because I know a lot of students like seeing it the other way. So 1.25 Y plus the 80 cents X, that the expenses have to be less than or equal to 20. All right, so we have this here, and our first step to get our Y isolated would be to take the X variable to the other side. We know that the 80 cents, hold on, my screen is a little bit tripping out. Oh, I guess it's not tripping out. Okay, so we'll take the 80 cents to the other side. I'll go ahead and write it as 0.80, save some space, 0.80. That's going to be taken side by subtraction, and that's going to now leave me with, come on. Oh, that's why I got to press right here. Got it. Okay, thought my screen was frozen. Now I have $1.25 for every sports drink, less than or equal to negative 0.80x plus 20. Okay, we then take 1.25 to the other side by the inverse operation, which is division. We're going to do it to every single term on the other side. That's going to cancel out my 125 because it makes 1. Anything divided by itself makes 1. So now here is pretty much our final answer. We have y is less than or equal to. Now this here is going to give us, I'll write it down, but if you put this in your calculator, it's going to give you negative 0.64. But you need to understand that this is going to be my slope. I want to see my slope as a fraction, as a rise over run, right? Rise over run. So if you understand how to use the calculator, you could use the green button on the top left of the calculator, which is second command, and then you can press it looks something like this, fraction, decimal. So you got to find this command here in your calculator where the calculator will go ahead and change from fraction to decimal and vice versa. So when you do that, it is going to turn that into a negative 16 over 25. That is what it turns out to be. All right. So if you grab negative 16 and you divide it by 25, it'll once again give you negative 0.64. All right, x, and then here we have 20 divided by 1.25. That is going to give me positive 16. Done. Here is my inequality that needs to be graphed. Here I have it. Now, the way that we graph this, according to the last video that we did, was we literally go backwards into this, right? Going backwards will literally paint a picture for us. So starting with this right here, which is going to be our y-intercept, that is going to be the first thing that we're going to do. We're going to go to our graph, and just to paint a picture for ourselves, my x numbers are water bottles. Okay. And then my y numbers are going to be sport drinks. I'm just going to put sport. Okay. Sport drinks. So I will go ahead and put a point at 16, 14, 15, 16. Okay, that is my y-intercept. And then from there, I am going to use my next value, which is located right here, which is my slope. That is going to be my staircase, or the rate of change, or the little ladder pattern that we got going on. So you could see that this slope is negative. That means I have to go downwards. My line has to go downwards from left to right. It needs to go downwards. So that means that I'm going to go down 16, which takes me, if I go down 16, it'll take me down to 0. And then I'll go to the right, so it can take me to 25. So that means that I will be right. Whoa, let me see. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, I was right. It's the number is very blurry. Okay, there it is. So I got my y-intercept, I got my slope, which my next point was actually my x-intercept. So I went from my y-intercept to my x-intercept. And then the next thing that I can get from this is I have a solid line. So notice that we literally worked with everything from right to left. Y-intercept, slope, and then this right here is telling me what type of line I have. And then together here, it'll tell me where my shading is going to go. So my line is a solid line. Let's go ahead and create a solid line. From here to hither. All right. And there's a solid line. The last thing I'm going to ask myself is, where does the shading take place? Well, the little, you got two options. You got two options here. You can either go ahead and choose a point and test it out, or you can use the cheat code that we know right here. Since this is already in slope intercept form, if we read it, it says y is less than. As soon as I see that it's less than, I think under the line. Less than is under the line. Less than is under the line. Now, if you use common sense, we're talking about a budget here, right? We're talking about a budget here. That means that, let's look at this point right here. If you buy 11 water bottles and 4 sports drinks, that's not that much. Imagine if you were to buy 20 water bottles and what number is that? 14. I think that's 14. 13, 14. And 14 sports drinks. That's a lot more. So hopefully you understand that the higher you go, up and to the right, right? The further you go up and to the right, that means you're spending a lot more money. So if you stay closer to the origin, the closer you are to the origin, the less money you're spending. So it makes more sense that the shading does happen in the bottom. All right, so let's go ahead and finalize that idea. Shading happens in the bottom. My solution set lies everywhere under this line. Not only does it lie under the line, but is also the line. Remember, since the line is solid, it means that the line, anything that's on the line, will also be part of my solution. I want to go ahead and put it a little nice and light. I don't want it to be like an eyesore. All right, there I have it. So all these combinations are the possible combinations that Dominic can use. We can literally just look at this and very quickly determine if that combination will be within the budget. So random point right here, 7 waters and 8 sports drinks. Yes, he can afford them. You can actually test that out. You can grab your calculator and multiply 7 waters times their price of 80 cents plus 8 sports drinks times the $1.25 that they cost. You're going to see that that's going to be less than $20. Now, this is what I'm going to do. I am going to choose a point that seems to be located on the line. And then I'm going to take you guys to Desmos to check something out. Look at this point right here. Okay. I am going to test out this point right here, which looks like it's on the line. I want to see where that actually is. That means that we're buying 14 waters and 7. We're buying 14 waters and 7 sports drinks, right? So the question is, can we afford that? Well, let's see. I'm going to go and do this the formal way. I'm going to go ahead and write the entire inequality that we had before. $20 is more than the 80 cents per water. And right now we're buying 14 waters. And we're also buying the $1.25 7 sports drinks 7 times. So I'm not going to write that. I don't want to keep repeating that. 80 cents times 14 gives me $11.20. Okay, so 1.25 times 7, that's going to give me $8.75. Together, this gives me $19.95. Whoa, that was close. So, is this true? Or can this happen? Yes, that can happen. This is actually so let's talk about this for a second. This point, even though it looks like it's on the line, it's literally on the line. It looks like it's actually not. It's not on the line. We learned in the last video that a point on the line will generate the same exact numbers on both sides here. Same exact number. The line is pretty much that fence, okay? The fence that will say you're either above that number or below that number. So when you're on the line, you're exactly at that number. For example, anything under here, you're going to find yourself under 20. That's why it works. That's why it's our solution, because we're under $20. Anything up here, you're going to be above 20. That's why it's blank and not shaded, because it's more than $20. It's not within our budget. Now, this right here, $19.95. So close. It is so close. The closer you get to that line, the closer you're getting to $20 being spent. So let's go ahead and jump to Desmos really quick and see what that looks like. I already have it typed up here. You can see here that we have a y-intercept of 16 and a x-intercept of 25. And where was that point? That point was 11. No, was it? What was it? 11 commas. I gotta go back and check. Oh, 14,7. 14,7. So that's where my point is at. It looks like it's on the line, but what happens when I zoom? Zoom, 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 zoom. Oh, very, very close call. You see that? So that is why that did not generate $20 exact. Now, something pretty cool is if you grab your calculator right now and you calculate this, look at your y-intercept and look at your x-intercept. Your y-intercept means it tells a story. The X number right here is 0. That means water. That means we didn't buy water. Dominic did not buy water here, and he decided to buy 16 sports drinks. If you grab 16, which is the amount of sports drinks that we are shown here, and you multiply that by $1.25, what do you get? You get $20 exactly. Why? Because the dot is on the line. All right, go to your x-axis, the 25, 0. 25 is x. X is the number of water bottles that we're buying. How much are the water bottles worth? 80 cents. So if you grab your calculator and you do 25 times 80 cents, because you're buying 25 of them, how much money will you spend? $20. You see that? So when you're on the line, you're going to be generating numbers that are exactly to that number you're trying to match up to. If you're below the line, you're going to get obviously numbers that are less than. And if you're above the line, numbers that are above. So right now for this problem, we want numbers that are under in the shaded region because it's a budget. Now let's go ahead and talk about some common sense. Even though the shaded region is supposed to be our answer for everything here, well, let's talk about restrictions. Let's talk about things that don't make sense here. And this is a real world problem. Hopefully you know where I'm getting to. If you go back to the graph area and you look at the points 5, 3.25, 3.25 here, is this part of the shaded region? It is. This point is part of the shaded region, but in this problem, it is not an actual solution. It is not a reasonable solution. So even though, or we can put although, this point is within the shaded region, it is not, what was my wording? Wow, I just went blank. It is not reasonable. There you go. Reasonable to use fractions or decimals with this real world problem. It does not make sense. Not with this one. We can talk about other problems that uses fractions and decimals that are real world, and yes, we can. But this one right here talks about buying 5 water bottles and then 3.25 sports drinks. You can't do that. When you go and buy stuff, you got to buy the whole item, right? So you cannot break that into parts. Cool. All right. So that's pretty much it. This is the breakdown of understanding a word problem and how we can use linear inequalities or 2 variable inequalities to graph it and make sense of the answers. All right. Example number 4, how to generate the equation, aka the inequality, the math sentence that makes the graph. All right. So we have a graph here that's shown to us, and now we want to work backwards. We want to work backwards. So let's use our brain right now to think this backwards, right? What do we notice? What can we see here? We see several things. The first thing I can notice right off the bat is that we're using a dashed line. Since it's dashed, I'm going to put here dashed. That means we're working with the greater than or less than symbol, right? Next, I could see that my line looks like this. It's negative, so it has a negative slope, but also that we're shading under it. Okay, we're shading under. So that means that we're actually using the less than symbol. So we are using this symbol right here. We are using the less than symbol. So what does that mean? We already know the start of our inequality. Y is less than. All right, let's go ahead and go talk about the slope once again. Look at this line. It has a negative slope. So I know that, first of all, my line is going to look like this. Y equals mx plus b. I'm going to write it in slope-intercept form. But obviously, I'm not going to be using an equal sign. I'm going to be using an inequality sign, which I already have it there. All right. So I'll go ahead and put it. Okay. So what is my slope? I don't know what my slope is right now, but I know that it's negative because my line is going down from left to right. okay? A lot of the time students are like, what does it mean that it's going down from left to right? I want you to look at this right here, and I want you to see how the line gets revealed. And I want you to tell me if the line is taking you up or down. So right here, look at the line and follow it with your eyes. Where's the line taking you? The line is taking you downwards, right? It's a downwards roller coaster right there. So what we're going to do right now is we're going to select 2 points that exist on this line, but they are also in perfect intersections, okay? So if you look at this vertical line and this horizontal line, we have a perfect point right here of that line, okay? What I'm trying to say is this will allow us to pick out accurate points from that line. So that point is 1, 1. It's not a fractional crazy point. It's just 1, 1. If I follow along the line and then I keep looking for more, there's another one right here, okay? And that right there is going to be 1, 2, 3. So it's 3 to the right and then down 4. I think 1, 2, 3, 1, 2, 3, 4. Yeah, down 4. So we could just look at the vertical and horizontal. So I need to go down 1, 2, 3, 4, 5, vertical of 5, and then horizontal of 2. Remember that slope is rise over run, meaning the vertical movement over your horizontal movement. Okay, so check, check, check. I'm going to go ahead and put X right here. And then lastly, I need to find the y-intercept. My y-intercept is located in my y-axis where my line crosses the y-axis, which is right there. Now, this looks like it's very close to 5.5. I'm sorry, not 5.5. 1, 2, 3.5. This looks like it could be 3.5, but since I don't want to make that assumption, I'm going to use actual facts to test it out. I'm going to see mx plus b. I'm going to go ahead and use facts to test that out. So what I'm going to do is I'm going to input numbers into this right here so I can find what my y-intercept is. So the first question that I have is, do I have any x's and y's that I can input here and here? Yes, I do. I have 2 points actually. I have this point right here and that point right there. They both have an x and a y. Which one do you think it's easier to work with? Well, I don't know about you, but this point right here is a 1 and a 1, and doing math with a 1 is super simple. Okay. Now, sorry, what I'm about to do right now should not have an inequality. This should just have the equal symbol because I want to find out what b equals to. Okay, so it should be an equal symbol. My slope is -5/2. My x value here is 1, and then plus b. You could see that the only thing that we don't know here is the value of b. So, it's perfect. 1 times -5/2 is the same thing as just -5/2. I'm going to go ahead and continue this by taking 5/2 to the other side. It's a negative fraction, and since it's a negative fraction, it wants to subtract with b. So the opposite of that would be to add. So I'm going to add 5 halves to the other side. So both sides, it'll cancel out from here. And here I will get 5 halves, right? 5 halves is 2.5. 2.5 plus 1 will give me 3.5. So we were we were correct in our guesstimation that this right here is b, which is 3.5. Okay, our slope, I'm sorry, our intercept, y-intercept, Jesus Christ. So at 3.5. And we're done. That's it. This is the line. This is the equation of the line, inequality of the line. All right, moving on to the next one. If you haven't paused it, pause it now. All right, so let's go ahead and talk about this. It's a solid line, right? That's the first thing I have in mind. It's a solid line. We're shading above the line. So here's my starting equation. Y is greater than or equal to. I'm saying greater than because we're shading above, and the equal to because the line is solid. Then what do I see here? I see a point that exists on the line here. I see another one right here, which happens to also be the y-intercept, okay? This point right here, and this also possible point right here. Now from here, we can go ahead and get the slope. It doesn't matter which 2 points you use to get the slope. It doesn't matter which points you use to get the slope. You will always get the same thing. Trust me. Notice that we have 3, 1 here, right? That's a 3, 1. What if I actually chose to go from this point to this one? Well, then you have 6/2, right? So the red one was this 3/1. Well, isn't that the same thing as the green one, which is 6/2? because 3 over 1 is just 3. 6 divided by 2 is just 3. And then lastly, you can go ahead and do right here, and that's going to give you 9 over 3 in blue, okay? Which will be 9 over 3, which all of this just equals to 3. It doesn't matter which point you choose to do your slope. All right, people? That's what I'm trying to say. Okay, so my slope is 3. And it's a positive slope because my line is going up from left to right. So I can go ahead and write 3x. Now, what is my y-intercept? I did say that it's -1, but just to be 1000% accurate, what I'm going to do is I'm going to go ahead and select 2 points. This is going to be my first point. That's -1. Actually, sorry, I'm going to choose 1 point. -1, comma, 1, 2, 3, 4. -4. I am going to use this x and y and plug it into my slope intercept form, y equals mx plus b. So the y value of that point is -4. The slope of that line is 3. The x value is -1. And b, or the y-intercept, is what I'm trying to find. Now that's going to be -4. 3 times -1 is -3. I take 3 to the other side here by adding, because this 3 is negative. Do you notice that my -4 plus 3 will give me a -1 for b, or the y-intercept? So yes, that is my y-intercept. There we have it, and we're done. Bada bing, bada boom. All right, guys. Kill it. Have fun. Peace out.